My name is Devan from Malaysia. Let me get this clicker. Okay, so today I'll be talking, I hope you guys are all awake after the lunch. So we'll be going through some waste treatment topics, and as my previous presenters have already showed on the issues of waste management, I'll just rehash with a different approach to composting as well. So just to give a bit of a background, why is proper manure management or waste management important? As you can see, firstly, it's also a handling issue, moving wet manure from one area to another, additional costs for transferring, disposal, not to mention the biosecurity risks by transferring from one area to another. As my previous presenters have showed, the pathogenic diseases that would be spreading around mostly through manure or untreated manure that's being moved from one area to another or transferred by wild birds and so on and so forth. So another major impact with improper waste handling and also the overuse of chemical fertilizers is you have a lot of runoff of the material if you do dumping, for example, into the soil. There's a lot of NPK or nitrogen runoff into the rivers, causing eutrophication. And this destroys the biodiversity, not only on land, but also in the water bodies near the farms or throughout the country. Another issue would be greenhouse gas emission, and that I have a few slides on. Also, these systems would emit quite a bit of ammonia, which then contributes to the greenhouse gas problem. And also, authority enforcement depends on the country. Some countries have very strict enforcement over waste management policies. Some countries even, it's a must to have waste management treatment centers together with the farm. As what we were mentioning earlier from my earlier presenter, for instance, like in Japan, if you build a farm, you have to have a waste treatment disposal system, a proper one. Otherwise, you do not get the permission to even start or build a farm. So what are the long-term effects of intensive agriculture and intensive use of chemical fertilizers? So earlier you saw the previous presenter as well about talking about compost and its benefits. This is similar to that, but the main fertilizer that's used in the world right now is chemical fertilizers, NPK chemical fertilizers, and this has an adverse impact. The overuse of it has an adverse impact on the soils. So what happens is you get a lot of biodiversity loss, and the nutrients, the NPK is actually the ones that are not being absorbed by the plants are actually going into the water bodies and not only degrading the soil, but contributing to water scarcity as well. So we, part of the business development team, we've been trying to build a bit of a circular economy around farms or farming in the farming community. So from the farm, we are producing protein, then you get the waste out of it. The waste through composting can be used as organic fertilizer to go back into the crops. And from the crops, again, that could be made into feed, and the feed goes back to the farmer in forms of feed to grow more protein. And so that is the circular economy, or the circle of life, as we have written over there. Yeah, so we believe that manure is not a waste, but rather a soil amendment, a source of soil amendment, or a source of profit. So how do we go about this? What is composting? You can do it traditionally, which is just by piling manure in a pile, letting the temperatures rise. It takes a long time, but at the end of it, the bacteria inside that's already active in the manure would slowly break it down into compost. So important factors are the temperature of the piles, or the temperature of the bacteria that's producing heat. It's exothermic. So that's usually around 60 to 70 degrees of core temperature. Again, depending on the moisture level. There is also an optimum moisture level of around 55 to 65% moisture, or, well, for dry matter, could be up to 25 to 45% dry. And what we are going to show you today is aerobic fermentation. So unlike biogas systems that are anaerobic, where it's fermenting to produce methane, it is different bacteria that we are cultivating that's already existent in the manure. And all we're doing is supplying oxygen and agitation. So, yeah, this is a bit on the traditional form. This is called windrows, where you just put it in rows. You have a bobcat or a front-end loader agitate the manure as you go along. However, you require very frequent agitation. It is, though, a very low investment required, but you need a very large space, large footprint, maybe suitable for very small farms or small amount of waste. A very long processing time. This can take 60 to 70 days or sometimes even longer. And again, it's very dependent on the temperatures. So if it's a rainy season, it'll probably take longer. If it's drier, then it'll take a little bit shorter, but it's very weather dependent. Now, odors in this kind of a case, you'll be emitting quite a lot of odor. So you will get the ammonia smell, hydrogen sulfide, among other chemicals that cause odor. Also, we've noticed a lot of a fly infestation problem usually occurs at a lot of these kind of farms if the agitation is not done frequently enough. And this could be a problem for the surrounding areas, or if you have residential areas nearby your farms, this could be a serious problem with complaints from your neighbors. Now, the other technique, what we just saw earlier, my previous presenter, would be doing horizontal composting. This is where you have a machine that will move up and down, agitating in a row, but it's a bit more mechanized. Now, this is usually semi-open, where you have a kind of a closed house. Now, you require these machines to agitate the system. However, as you saw earlier, you do require to adjust things like moisture or add certain kind of bacteria to the piles to get it within the right range for it to have efficient composting or feeding the bacteria that is required to do the composting. Now, this would be a medium investment. You still have to build a building, concrete construction for the rows. You have to buy the agitators. Now, it is also a decently long processing time, depending on the system, 30 to about 40 days, shorter than just leaving it out in the open. But out of 30 to 40 days, it's also still quite weather dependent. So if you have rainy season, usually you tend to re-wet the manure, which will make your processing time a bit longer. Now, odors here, there are systems to try and help out, but it is very difficult to manage because it's still out in the open. And fly infestations can occur, not as much as the previous one. So I would like to show to you now another technology that can enhance or make manure processing more efficient, which is in-vessel type composting. So instead of putting it in a row and agitating mechanically, we have an enclosed vertical system. So this is like a tank that's specifically designed to carry an X amount of your fresh manure. We have inside the machine, and I'll show you in the next slide, agitators and blowers to continuously blow air to feed the bacteria. However, you do not need any additional things like sawdust or adjustment on moisture levels. It just has to be within a range, and because this in-vessel technology is enclosed, it is a lot easier for us to harness the energy or the temperature from the bacteria and cultivate it to break it down faster. So the processing time is not weather dependent at all, and compared to, say, 30 to 40 days, depending again on the moisture level, it would be, for this type of systems, between 5 days if it's very dry, to about 12 days if it's extremely wet, like fresh out of a layer house, for example. So this would be a longer processing time, but still much shorter than the previous technologies, because we have the temperatures produced by the bacteria are inside an insulated tank. So we have insulation around the tank. This keeps the temperature inside, And yeah, so it would sustain the breakdown a lot faster and a lot more efficiently. Now, with this type of systems, odors are a lot easier to control because we have a piping or an exhaust stack on the top of the tower, and I'll show you in the next slide, where we can take the air out and clean it either by deodorizing it with using water or completely removing the ammonia using acids, really depending on the farm type and the investment. So this is what it looks like, a bit of a cutout of the tank. We have an insulated tank, stainless steel inner walls. This one has glass wool insulation actually. Stainless steel inner walls, so because manure is very corrosive. You have mixing blades with perforated holes on the inside, and that would, with the aid of blowers, continuously blow air through the blades and agitate the manure. Yep. All the machines, or the blowers, and the hydraulic systems to move the blades are all located at the bottom of the tower, or the bottom of the in-vessel machine. And it is a very small footprint. Now again, it's depending on how much manure you want to process. This is a much smaller footprint because it's vertical compared to the other more traditional methods that require quite a lot of land. Yep, and we have a few types of systems, the way you can input manure in. One is using conveyors automatically into the tower. Or for customers that do not want to have that form of investment, what we can do is we have a bucket. So, and I'll show you in the next slide, the bucket will actually, we can fill up the bucket, and with a touch of a button, the bucket will flip over and fill up the tank. So the main benefit of in-vessel composting would be the killing of the pathogens or inactivation of the pathogens that's inside the manure. Now, the key to killing pathogens, as you can see in my table here, would be temperature inactivation, which would mean you need to sustain temperatures of 60 to 70 degrees or 60 degrees at a minimum for at least an hour or a bit more. What we do with in-vessel technology is, because it's insulated, we are keeping the manure for say 5 to 11 days continuously at a temperature of 60 to 70 degrees Celsius, no matter what the weather is outside, and also no matter how you actually distribute the pile or agitate it. So this means that all the compost that comes out of the tank will be completely odorless. It will smell like soil, not like manure, and all the pathogens would be killed. So it would be safe for you to sell or to even transport from one area to another. So these are just the temperature gauges that we have on the side of the tank and also in a panel. And it shows these are actual operating machines. It is always running at about 70 degrees Celsius for a very prolonged time, where we are evaporating the moisture to make it much drier. So the wetter your input manure, the longer it's going to take, but you're still evaporating a lot more moisture from the manure. Okay, let's see if, oops. So this is just a short video on how it's going to run. Can we get the video on the left to start playing? The one on the left, yep. And can you mute it, please? Mute it. Yeah, there's a lot of machinery sounds in the video. So yeah, it's as easy as filling in the bucket with a loader, as such, with a flip of a switch. The bucket will be carried up via a lifting system. It's a chain type system that would then lift it up and dump it in to the top. So all you have to do is keep filling the bucket, and the bucket also acts like a kind of a dosing machine. Once it's placed inside, it is then closed up on the top, so it's completely sealed, and then we give the bacteria a chance to thrive, basically, and help break down the manure into what we call as compost. Now, after placing in the manure, as in the video on the left, you can see the video at the center. This would be after 5 days, 5 to 11 days, depending on the moisture level. You would get out this hot compost that is coming out of the machine. This is usually at about 70 degrees Celsius. By the time it comes out, it'll be about 50 degrees Celsius. It'll drop down a bit to show that the bacteria inside or the heat production by the bacteria is slowing down. So not eliminated, but it's starting to slow down, which means it's time that you can withdraw the compost from the towers. And after that, it's usually cured for a few days to cool the temperatures down. The reason for that is very hot compost, if you bag it directly like in the video, you tend to get a bit of evaporated condensation of water inside the bags. So you would get mold and everything that would start to grow, shortening the shelf life of your organic fertilizer or compost to be sold. But we do have some clients that would directly bag it and immediately sell it off too. It really depends on how you want to actually market your compost brand. So this is just a bit of a layout suggestion. We usually have these towers connected directly via conveyors to a storage room. So you can see here, it is pushed straight into piles inside the storage, cured for 7 days, then you can bag and you can sell it as organic fertilizer or compost. You can also see at the top, we have these 2 stacks that are coming up. Those are actually exhaust stacks that go through a deodorizer. So we also have systems. This exhaust comes up at about 8 to 9 meters in height. So it gets dispersed over a wider area. So the perceived smell on the ground is quite a bit lower. However, if you do require any additional cleaning, we can always try to clean the air by pushing the exhaust through a body or column of water or through sulfuric acid. And this would effectively neutralize the ammonia smells, and so your only emission would be water vapor. And this would not have any odor causing to any surrounding areas. So you can even have a house right next to one of these tanks, and there would not be any odor or smell associated with the production of compost. Yeah, so just to continue on building the circular economy, there's another benefit to this type of in-vessel composting technologies. Would be the idea of carbon credits or reduction of carbon. I think all countries have a target on how much CO2 or greenhouse gases they are supposed to reduce in the next 5 to 10 years or the next 15 years. So for those targets, another option is using this kind of technology. And we have actually proven it, where you have using some of these towers, and we have done what's called a life cycle assessment. So we have measured what are the CO2 gases that are being emitted by such a system compared to, say, using traditional horizontal composting techniques. So that is the baseline that we used, and we were able to measure that there's quite a significant reduction in CO2, which could then be monetized by you, the customer, in form of carbon credits as another form of revenue that could help pay back such a system. So, yep, that concludes my presentation. And thank you very much for listening. Cheers.